Thank you, Didier, and welcome everyone. So I will start and my colleague Bruno Lapillonne will take over in a few minutes. So this webinar is organized in the framework of the well-known project that has been going on for more than 20 years now in Europe, the Odyssey project, which is supported by the European Commission. And the project is coordinated by ADEME, the French Agency for Energy Transition, with the support of Enerdata and Fraunhofer. So the project covers the EU 27 plus UK, Norway, Switzerland, and Serbia. And the national partners of the project are mainly energy efficiency agencies or ministries. So the project has two main objectives. The first one is to evaluate and compare energy efficiency progress by sector in relation to the trends on energy consumption and indicators and to the EU targets. So this is the Odyssey part, and this webinar relates mainly on this part. The second part is a MUIR part and is linked to energy efficiency policies and measures that are implemented. And also the aim of the second part is to see what are the best policies. You can find a lot of information on the website of the project that is given here. You have a database gathering all the data and indicators, but also 5 data tools and some analysis and publications at country and EU level. So as I said before, the webinar is based on the Odyssey, on data and indicators that have been prepared in the framework of the project. The data have been updated until 2019 from national sources. And in order to have the most recent trend analysis, we have tried to estimate data at EU level for the year 2020. So these estimations have been prepared by Enerdata through a methodology that is available through the link provided at the end. So this is the content of the webinar. So first, I will present you the energy consumption trends and the energy efficiency trends by end use, so at a very detailed level. And then I will leave the floor to my colleague Bruno, who will describe you the energy efficiency trends at sectoral level and some preliminary results on energy efficiency for the year 2020. So first, the trends on energy consumption. So here we show the trends on total energy supply. What is total energy supply? Is the total energy demand of a country. So it covers the final consumption by end user, but also the consumption of the energy sector itself, meaning the losses during transformation and distribution of energy. So here we analyze the trends of total energy supply, GDP, and the primary intensity, which is the ratio between the total energy supply over the GDP. And we show the trends here for EU 27. So what we can see in the graph of the bottom, we have the trends in annual variation. On the graph on the end, we distinguish 4 periods according to the economic activity. So before, during, and after the 2007 crisis, and for the year 2020. We can see that there is a stability of the EU total energy supply over the period 2014-2019, and this also the GDP increased by 2% per year on average, with a return to economic growth. Then for the exceptional year of 2020, total energy supply, but also the GDP decreased by 6%. And consequently, the primary consumption is estimated to be around 6% under the EU target for 2020. If we look at primary energy intensity trend, it has decreased slightly more rapidly over 2014-2019 by around 2% per year than over 2007-2014. And for the year 2020, we observe a very slow reduction of primary intensity. So now, how can we explain the trends on total energy supply between 2014 and 2019? In the Odysseus project, we develop a methodology on decomposition analysis to evaluate the different factors behind energy consumption variation. We have a tool dedicated to this. I invite you to consult it. And here I show you the decomposition analysis for total energy supply. So as I explained before, total energy supply covers final consumption, but also the consumption of the energy sector itself. For the EU, the energy sector consumption is mainly composed of the consumption of the power sector. So in the graph here, the blue bar represents the total energy supply for 2014 and 2019, and the other bars are the explanatory effects. We observe that total energy supply increased less than final consumption by around 17 MTOE compared to 36 MTOE for final consumption. And the lower progression of total energy supply compared to final consumption is mainly due to two main effects represented in green in the graph. The first one is a change in the power mix. The power mix is a share of renewables, nuclear, and thermal plants in the electricity production. And as the different energies have very different efficiency, if the structure of the power mix change, all things be equal, it impacts the losses of the power sector. So at EU level, renewables share in the power mix increased from around 25% to 29% between 2014 and 2019, while thermal share decreased by 2 points and the same for nuclear. So this impacted the total energy supply over the period. The second effect is the increasing efficiency of thermal power plants. Both the replacement of old thermal plants, but also the shift from coal to gas allowed to achieve an average efficiency of 38 in 2019, which is 2 points higher than in 2014. So these two effects, moving for more renewables and more efficient power plants, contributed to decrease total energy supply by 18 and 19 MTOE respectively. For the year 2020, the results are not presented here, but are very quite similar than for this period. Total energy supply decreased more than final consumption because of an increased penetration of solar and wind. Now, if we look at the trend on final energy consumption, here we show the trends in terms of average annual variation for final at left side and for electricity at right side, and both by sector. We observed that final consumption grew again over 2014-2019 with the economic rebound by around 0.7% per year on average. And this contrasts with the total energy supply trend. Now, if we look by sector, transport was the most dynamic sector since 2014, with an increasing consumption by 1.4% per year, which is a trend similar to the trend before the 2007 crisis. On the other hand, industry had the lowest progression by 0.3% per year, increasing consumption. Now, if we look at electricity consumption, it grew at an average pace of 0.6% per year. And this contrasts with past trend. Before 2007, electricity was the fastest growing consumption due to the penetration of IT equipment, due to industrial automation. So it increased by 1.9% per year, again against 0.6% per year, as I said before, for final consumption. Now, if we look at the trend for the year 2020, final consumption decreased by 5.6%, and transport consumption dropped by 11% due to lockdown and travel restrictions in many countries. Households were the only sector with an increase in consumption as people stayed longer at home. Its consumption increased by 1.4%. And services registered the highest decrease in electricity consumption, minus 7%, due to massive teleworking and the temporary closure of bars, restaurants, etc. So now that we have seen the consumption trends, we are going to look at energy efficiency. So the question is how we can measure energy efficiency progress is a trend presented previously. First, we will see the trends at subsector level, and then Bruno will present you at sectoral level. So what I call subsector level is, for example, the end use for households, for cars in transport, etc. So in the ODCMU project, we measure energy efficiency progress at very detailed level by subsector and by end use through a wide variety of indicators of specific or unit consumption. And all these indicators are in physical units to be closer to the assessment of energy efficiency, but also to get rid of economic factors that affect macroeconomic indicators such as energy intensity. So for example, we use for transport the specific consumption of cars in liter per 100 kilometers. For household, we use the specific consumption per square meter for heating. And for industry, we use for energy intensive products the specific consumption in TOE per ton of product. So now I will present you the trends observed for three end uses: for cars, for household space heating, and large appliances. But you can find much more indicators and analysis in the website, and especially in the key indicator tool. So first, here we show the trend on specific consumption of new diesel and gasoline cars expressed in liter per 100 kilometer, which is one of the best indicators to monitor energy efficiency progress for new cars. What we observe is that there was a reduction in the specific consumption of new diesel and gasoline cars until 2014 by 1.8% per year on average for the EU. And then we can observe a reverse trend since 2014 in most countries and in the EU 27, or a net slowdown in the other countries. And this increasing specific consumption since 2014 can be explained by two main factors. The first one is a decrease in the share of diesel car sales. The diesel car sales decreased from 55 to 34% in 2019 at EU level. And even for some countries, like in France, the drop has been more important. And as diesel vehicles are usually more efficient than gasoline vehicles, so it contributed to the growth in specific consumption. The second factor is a growing share of SUVs. The share increased from 25 to 40% in 2019. And as SUVs are bigger, they consume more. So again, it contributed to the specific consumption growth. If we want to see what has been the energy efficiency progress for car stocks, so for all the cars on the world, we prefer to look at the unit consumption of cars per passenger kilometer. And what we observe is that there is a much lower progress for the car stock than for new cars. And several reasons can explain this. First, the fuel mix with the penetration of biofuels like biofuels have a calorific content value lower than for diesel of gasoline. The second reason is the occupancy rate, which is decreasing over time. For instance, it decreased by 7% in France or Belgium or Germany, and by more than 30% in the Netherlands over 2019. And the third factor can be the fact that there is a gap between the test values and the real driving condition values of the specific consumption, and this gap is changing over time. So all these factors explain why the energy efficiency progress of the car stock is really lower than for new cars. Now, if we look at space heating for household, we usually use the specific consumption of household for heating at normal climate per square meters to assess energy efficiency progress. In the graph displayed here, we show the trend for the largest EU consumers for 2 periods. We observe that the indicator has decreased in almost all countries, meaning that energy efficiency is progressing. And at EU level, it progressed quite rapidly by 1.7% per year on average. But what we observe is that the trend is not homogeneous over the period. In fact, energy efficiency progress has slowed down at EU level since 2014 because the rate was 0.6% per year after 2014 against 2.1% before 2014. And also in several large countries, for example, France and the Netherlands, and even we observe a reverse trend in Germany. So why energy efficiency is slowing down since 2014 for heating? We find several factors that can explain this. First, there was less new construction. Since the 2008 crisis, the new construction strongly decreased, and even it started again to increase in 2016. The annual construction in 2019 is 30% lower than the amount constructed in 2007. The second factor is the quality of renovations and construction of buildings, because there is a gap between the theoretical unit consumption of new buildings or buildings after deep renovation and the real unit consumption, because the quality of works is deteriorating. Another factor can be the slower diffusion of efficient heating modes, like condensing boilers, because we may have achieved a saturation level for some equipments. And finally, rebound effect, even if it's quite difficult to evaluate, because new homes are becoming better insulated, then people may tend to heat more the buildings. So all these factors can explain the slowdown of energy efficiency progress for heating. Finally, if we look at appliances for households, the best energy efficiency indicator is the specific consumption measured in kilowatt hour per appliance per year. And here we show the trend for the largest appliances at EU level since 1990. We can observe actually that the specific consumption of large appliances has decreased quite steadily since 1990, thanks to the labeling and eco-design regulations that have been regularly updated and also reinforced. And at the end, the efficiency gains are above 40% for refrigerators, washing machine, dishwasher, and dryers, and a little bit lower for freezers. So now I will leave the floor to Bruno to go ahead on energy efficiency trends at sectoral level. Thank you.
Thank you, Laura. Welcome, everybody. So now I will see how we can measure energy efficiency progress at the level of sector. We have seen that, for instance, for household, we have different trends for heating, refrigerator, water heating. And the question is, but what is the overall energy efficiency progress at the sector level of household, and the same for the other sector? So this is the objective of an indicator we have developed within the Odyssey project that we call the Energy Efficiency Index, in short, the ODEX, that summarize the trend by sectors and for all final consumers. How is ODEX calculated? It is calculated first by expressing the trend in specific energy consumption by end use or subsector as an index of variation, so as to remove the unit. Then by calculating the average index of the sector by weighting all these index by end use by the share of each end use in the sector's energy consumption. ODEX is calculated on the basis of 40 subsector now in the Odyssey project, 8 mode of transport, 11 end use, 14 branches in industry, 6 branches in services. It can vary according to the country, depending on the sectors that are important and the data available. This approach enabled to mix specific consumption indicators that are expressed in different physical units, as you have seen from the presentation previously. From this ODEX indicator, we can see that the energy efficiency progress of final consumers has slowed down from 1.2% per year over 2040 to 0.7% per year since 2014. So we see for all sectors, what was shown earlier was for car and heating, we have really this slowdown of energy efficiency progress, despite the fact that the policy seems to be amplified. Household is the sector with the greatest progress. When we review all the sectors, this is the bottom line since 2000. But we have, as explained by Laura, the rate of improvement is twice lower since 2014 than before. In industry, the slowdown started in 2007, so just before the financial crisis. And since 2007, the rate of progress has been divided by a factor 2. Transport is the sector with the lowest improvement, despite there have been a lot of policy forecasts, despite the fact that at least until 2014, there were a strong progress for cars, as we see from the test value, but maybe not for the real condition of driving and for the overall stock of cars. And also, since 2014, we have a slowdown, which means that the progress is twice lower since 2014. Services seems to have better results since 2014, as opposed to the other sector. Now, this energy efficiency progress represents the amount of energy that is not consumed, and we are able to calculate these energy savings. And in 2019, we estimate that they represent 21% of the final energy consumption, which means that without these savings, the final consumption would have been 21% higher. Since 2014, following the slowdown in the energy efficiency progress, these savings have been twice lower for transport and household. The graph below shows the magnitude of savings obtained from the different sectors, and households represent the largest share, and they are even overrepresented if we put in perspective their share in total savings, which is half of the saving, compared to their share in the consumption. Sorry, their share in savings 44%, and their share in consumption is 27%. In transport, this is the other way around. The share in consumption is much higher than the share in savings, about a factor 2. The good results for our soul are explained by the fact that there have been a lot of measures, especially at the EU level, for building, for appliances. In transport, there have been measures for cars, but less for all the other sectors. Now, what can we say about the variation of the final consumption between 2014 and 2019? Here, we make use of the calculation of savings by sector, end use, and so on. But we have to take into account also the effect of the economic growth, demographic growth, which is shown by the activity effect. And this activity effect also take into account the fact that there are more appliances per household, more cars, and also that the size of dwelling has increased. We calculated that the effect of economic and demographic growth, this activity effect, contributed to raise the final consumption by 70 million ton oil equivalent. But in reality, the consumption only increased by half this value, only 35 million ton oil equivalent. Half of this activity effect has been offset by energy saving, reducing the consumption by 37 million ton oil equivalent. We have other factors, structural effects, mainly change in the industry sector, but we take also into account the effect of model shift, usually toward car and toward trucks. But structural effects, which are mainly due to change in the industry structure, the fact the less energy intensive sector are growing faster and represent a lower share in the overall activity in industry, these structural effects have contributed to decrease the consumption by 6 million ton oil equivalent. And about the equivalent amount, but is the other way around, is the effect of the climate, the fact the climate in 2019 was colder in 2014, which explains an increase of 6 million ton oil equivalent. Now, what can we say on energy efficiency in 2020? In general, energy efficiency gets worse in periods of deep recession, especially in productive sector, in industry, in services, and in freight transport. We have a very good illustration with the year 2009, which was a year of recession. By the way, with a recession which was almost of the same magnitude as in 2020, but in 2020 there were different factors playing with a great effect on transport because of the lockdown effect. And the reason for this deterioration of energy efficiency in periods of recession is due to the fact that the energy consumption does not reduce as much as the economic activities, because the industrial plants are not used at full capacity. The boilers, the furnace, they have to operate, are operating less efficiently. The load factor for trucks is decreasing because of lower traffic, but trucks are still running. So this decreases their efficiency, and the same in services. So what we observe is a lower efficiency, but not from a technical viewpoint, because the equipment are the same as the year before. In 2020, we have the same equipment as in 2019, and some may be more efficient, but it is from an operational viewpoint. In 2020, public passenger transport was affected like this productive sector, mainly train, metro, and bus, because the lockdown and sanitary measures have led to a sharp reduction in traffic and load factor. And the worst affected was air transport. But in the definition of the final consumption, we only take into account the consumption of domestic transport, which is less important than international air transport. So public passenger transport was deeply affected. We do not have consolidated data at European level, but we have such data for France. And just as an illustration, and it is still based on preliminary statistics, we can see the big deterioration in the energy efficiency of passenger transport, with the unit consumption per passenger kilometers that decreased by 44% for buses and 67% for rail. And this is mainly due to the fact that the vehicles and the train were running at with very load factor. And the graph on the right show you what has been the impact on the unit consumption for public passenger transport, which imply big increase, 40 to 60% increase in the unit consumption, which correspond to a deterioration of the operational efficiency, but not technical efficiency. What else can we say about energy efficiency in 2020? It's clear energy efficiency has continued to improve because the new equipment, the cars, the appliance sold in 2020, or the new building built continue to be more efficient because of the regulation, because of different factors. But this is driven by the existing regulation. I will illustrate that in the case of cars. In addition, sectors that are not affected by regulation, but by support policies, like policy to retrofit buildings, have often continued to exist, and they are less sensitive to the crisis. It's not because there is a big crisis that the support, public support to the renovation of dwelling is getting worse. And what was surprising is because there is a big priority on social buildings as a way to fight energy poverty, the renovation of social building had jumped in 2020 in Denmark and France, and increase in Sweden, Germany, Finland, and Austria, all quite significant countries in the EU. So it means it had an impact in the EU, and these social buildings represent 20 to 30% of the building stock. So this is an interesting information. In this case, the energy efficiency has improved in 2020. However, and going back to the new equipment, new building, what has changed is the volume of new equipment and building in 2020. The car sales have decreased by about 25%. New construction has been lower by 20%. So of course, this lowers the effect of the penetration of more efficient equipment and building on the total efficiency of the economy. If we take the example of car, and the results are quite surprising, this is the test cycle value for a thermal car, diesel and gasoline cars in liter per 100 kilometers. So this corresponds to one slide that was shown before by Laura. But this is for, we have added the year 2020 in light blue. And what is surprising is that in 2020, the specific consumption of new thermal car, diesel and gasoline car, has decreased significantly by 5% at EU level, whereas it was increasing before, as shown by the orange bar. And we tried to understand, we checked a lot of explanatory factors, and the SUV or diesel share was not did not contribute to explain this decrease, because actually the trend, the previous trend was continuing. But what was significant is the fact the share of hybrid thermal cars that are included here has jumped from 6 to 12% on new registration. So it's probably the main driver for this significant decrease. And this probably was helped by the car manufacturer who tried to sell more efficient car, and I'm not talking about electric car, hybrid cars, for which the market share increased a lot also in 2020, because there is a standard in Europe for 2021, and the car manufacturers that are not meeting the standard will have to pay fines. So they have strong incentive to be quite dynamic on this market. So according to our first estimate, if we take into account the different sectors and using again the ODEX, we estimate that the efficiency of final consumers was a bit lower, taking all parameters into account, all sectors, than over 2014, around 0.5% compared to 0.7% before. Using the previous analysis also of decomposition of consumption, we can explain what happened in 2020. The final consumption decreased by 62 million ton oil equivalent. Most of the decrease is explained by the contraction of activity. Energy saving continued to exist, but had a small contribution, and structural effects were balancing this energy saving and contributed to increase the consumption, which is very typical of a period of recession. Let's look at transport, which was the most affected sector because of a lockdown measure. The consumption of transport decreased by 33 million ton equivalent. And this was mainly explained by the drop of traffic, almost the same magnitude, the orange bar. And because passenger traffic was the most affected, more than freight traffic, and passenger traffic represent normally 60% of the consumption. We can see some energy savings, we show the example of cars, but trucks continue to improve their performance. And the other factor in yellow correspond to the effect of the lower rate of occupancy in public transport. This is the way we capture it. In conclusion, over 2014-2019, and we can also include 2020, the growing share of renewables and natural gas in the power mix has offset part of the increase in the final consumption, or in 2020 has contributed to higher decrease of the total consumption. And this is something that will go on with the continued and increased penetration of renewables, which are counted with 100% efficiency, whereas they are replacing either nuclear or thermal power generation, which have an efficiency between 33 and at best 50% for thermal power plant. Energy efficiency improvement of final consumer has been 40% slower since 2014. We have already explained that a lot. And since 2014, energy savings offset half of the effect of economic growth. Almost all the sharp decrease in consumption can be explained by the contraction of activity linked to the COVID-19 pandemic. And our first estimate is to say that the efficiency of final consumers continue to increase, but lower than over the period before, slightly lower than the period before. I thank you for your attention, and I'm ready to answer to your question.